ASDIP WOOD includes the design of wood columns based on the latest NDS provisions, which calculates the adjusted design values for the required stresses and shows the design ratios accordingly. But how do you actually enter the information in the program? How do you check the results? How do you optimize the design in a real-life example? This is Javier Encinas, and today we're going to design completely from scratch a wood column subject to compression and bending. The column is 9 feet long and is subject to these loads. Dead load, 560 pounds, concentrated load. Snow load, 840 pounds. And wind load is a lateral pressure, 100 PLF, applied to the narrow side of the column. Assume dry conditions and normal temperature range. The ends are held in position and lateral support is provided at mid-span of the wick axis. The goal is to design the size of this column and the material. Let's go to ASDIP WOOD to model this example. When you open ASDIP WOOD, you see the project manager. Here you can see the modules included in the package: wood column, wood beam, wood bearing wall, wood shear wall. In this case, we're going to model a wood column, and I have created already a project with an example calculation. Double click on this node example, and this is the template of the wood column design in ASDIP WOOD. In the Geometry tab, we model all the geometric information. In this case, we're going to select from the database a 2 by 6 inches section. We can change it later if it doesn't work. Let's try this first. In a species region, we're going to select southern pine. This is the information given in the statement of the problem. The member length is 9 feet. The effective length in the strong axis is 1.0 because it's pin-pin. And the effective factor KY in the wick axis is 0.5 because the member is laterally supported at mid-span. The member material is going to be sawn lumber as opposed to glulam or a composite section. Let's go to the Materials tab. Here, if we click on the database, we can see the different options for this southern pine material. In this case, we're going to select grade number 1 for southern pine with these reference design values. Select this. So the material is southern pine, grade is number 1. And here are the reference design values copied from the database. The moisture content is 0, so dry conditions, and temperature is less than 100 degrees Fahrenheit. We go to the Loads tab. Here we enter the information that we know. The load, the concentrated load, is 560 pounds. Then snow is 840 pounds. And finally, in wind, we have 100 PLF wind applied in the narrow side of the section. All this was provided in the statement of the problem. We're going to design this example in ASD, but easily we can check also in LRFD if we select the other option. At the right-hand side, we go to the At a Glance tab. We can see a summary of the results. In this case, here we can see the adjusted design values. Then the slenderness, the section is also passing. The maximum slenderness ratio is 36 and the allowable is 50, so it's passing. Here in the combined stresses, the maximum stress in tension, compression, bending in one direction, bending in the other direction, and shear. And here at the bottom, the combined stresses, different ratios according to the NDS code. All these ratios are less than 1.0, meaning that the section is passing. If we go to the Contents tab, we can see a more detailed set of calculations grouped by topic. Here are the on-factor loads. Here are the adjustment factors from the NDS. This is the controlling load combination. The design is in ASD. These are the adjusted design values, which are basically the reference design values affected by the adjustment factors. And here at the bottom, the combined stresses discussed before. If we go to the Detail tab, we can see a more detailed set of calculations, step by step, group by topic, also with references to the corresponding section in the NDS code. Here at the top, we can see the section properties for the 2x6, the area, inertia, and section modulus. Here are the reference design values for the Southern Pine grade number 1. And here the calculation of the adjustment factors for this load combination, which is the controlling. Please note the column stability factor CP is 0.16, meaning that this is the percentage of the full capacity due to the slenderness of the section. Here are the adjusted design values for this controlling load combination for bending, tension, shear, compression, and so on. And here at the bottom we have the combined stresses for the same load combination, the calculation of tension, compression. We can see the comparison of the calculated stress versus the allowable stress, and in every case is passing. Here at the bottom the combined stresses, different equations in the NDS code. Everything is passing in every case, less than 1.0. Finally, the calculation of the bearing for this load combination. This is the maximum bearing load, so no bearing plate is required in this case. Finally, we go to the Diagrams tab. We can see the interaction diagram for this column. All these points in the diagram represent the loads per the load combinations specified. And here is the 3D interaction diagram for this image. It can be rotated. Let's go back to the at a glance. In this case, everything is passing. Probably we can optimize the design if we select a smaller section, but for illustration purposes, we selected 2x6. And as you can see, everything is passing and can be easily optimized if necessary. As you can see, it's very easy to design wood columns using ASDIP wood. We were able to check all the design provisions in NDS in just a few minutes, but if we try to do it by hand, probably will take hours. If you like the software, please visit the website www.asdipsoft.com and download the free 15-day trial. Please subscribe to the channel if you want to receive notifications in the future for similar videos. Thank you for your attention.